Welcome to an electrifying exploration of our universe. Today's journey into the cosmos is a tantalizing voyage, one that questions the very foundations of physics as we know it. We're about to delve into the electric universe theory, a fascinating proposition that electricity, not gravity, might be the primary architect of our universe. Ready for a shocking revelation? Before we dive in, remember to subscribe to our channel and help us grow our community, the legacy we leave. Let's dive in. What if gravity isn't the primary force shaping the cosmos? This question, radical as it may seem, forms the bedrock of the electric universe theory. This theory, emerging from the minds of innovative thinkers, challenges our conventional understanding of the universe's structure. The electric universe theory centers around the premise that electric currents, not gravity, are the primary architects of the cosmos. It suggests that electricity, with its far-reaching powerful forces, is the puppeteer pulling the strings of celestial bodies. Where did this theory originate, you may ask? Well, it's a product of decades of scientific curiosity and audacious questioning of established norms. The roots of the electric universe theory can be traced back to the early 20th century, with the works of pioneers like Christian Birkeland and Hannes Alfvén. These scientists dared to look beyond the gravitational paradigm, exploring the role of electromagnetism on a cosmic scale. In this electric universe, galaxies, stars, and planets are interconnected through a vast network of electric currents. These currents, invisible to the naked eye, sculpt the universe's structure, carving out intricate patterns across the cosmic canvas. This theory also posits that these electric currents aren't just isolated in the distant corners of the universe. They're here on Earth, buried in the geological layers of our planet, and possibly even woven into the fabric of our history. So how does the electric universe theory interpret the phenomena we attribute to gravity? It proposes that what we perceive as gravity is actually the result of electric forces. The planets in our solar system, the stars in our galaxy, they're all held together by these electric currents, akin to pearls strung on a necklace. In the electric universe theory, the universe isn't a passive stage where the drama of gravity unfolds. Instead, it's an active, dynamic entity, buzzing with electric currents that guide the dance of celestial bodies. And if this theory holds water, it could imply that our ancestors, with their myths and legends, were not just spinning tales of gods and monsters. They were perhaps describing cosmic events of electric nature. These electric currents may have left their mark on our ancestral myths. Ancient catastrophes, as told by our ancestors, may hold secrets of our electric universe. Delving into the annals of history, we find a plethora of myths and legends that recount cataclysmic disasters. From the biblical Great Flood to the fiery demise of Atlantis, these tales paint a vivid picture of a volatile past. But what if these stories were more than mere fables? What if they were, in fact, a record of genuine historical events? The electric universe theory suggests that these disasters might have been cosmic in nature, triggered by electrical phenomena on a galactic scale. Take, for instance, the Norse myth of Ragnarok, the end of the world, where the sky splits apart and the earth is consumed by fire. Could this be a reference to an intense electrical discharge event in the sky? Or consider the ancient Greek tale of Phaeton, who lost control of his father's sun chariot and nearly set the world alight. Could this be an allegory for a close encounter with a highly charged celestial body? These ancient stories, found across cultures and continents, hint at a time when the heavens were not as they are today. They speak of a time when cosmic electrical events were visible in the sky, causing widespread destruction on Earth. These events would have been both terrifying and awe-inspiring, forever etched in the collective memory of mankind and passed down through generations in the form of myths. The electric universe theory proposes that these ancestral tales could be evidence of a time when electricity played a more dominant role in shaping our cosmos. If true, it would require a radical rethinking of not just our interpretation of myths, but also our understanding of the universe. These myths might be more than just stories, they could be historical records. As we continue to explore the electric universe theory, remember that our ancestors' tales may hold more truth than we ever imagined. After all, the past, as they say, is a foreign country. They do things differently there. The implications of an electric universe reach far and wide. It's not just about explaining cosmic phenomena, but it's also about reimagining the very fabric of our physical reality. Imagine a universe where electric currents, not gravity, are the sculptors of celestial bodies. This theory steps into the realm of the tangible, as it's something we can test and observe in our own laboratories. Scientists have conducted experiments that mimic cosmic conditions, where plasma is subjected to electric currents. These experiments have resulted in formations eerily similar to spiral galaxies and nebulae observed in the cosmos, lending credibility to the electric universe theory. But the evidence isn't confined to the laboratory, it extends to our very own planet. Take the Grand Canyon, for instance. This magnificent natural wonder, with its layers of rock carved deep into the earth, has long been attributed to the erosive power of the Colorado River over millions of years. But proponents of the electric universe theory see something different. They see a landscape sculpted not by water, but by massive electrical discharges, a remnant of some ancient cosmic electrical event. This perspective paints a whole new picture of our universe, where planets and stars are bound not by the invisible chains of gravity, but by vast networks of cosmic electric currents. It's a universe more dynamic and interconnected than we ever imagined. But such a paradigm shift isn't easily accepted. Mainstream cosmology, rooted in the principles of gravity and relativity, has served us well in explaining and predicting cosmic events. The electric universe theory challenges this foundation, proposing a new lens to view and understand the cosmos. The theory challenges not just our understanding of the universe, but also the very foundation of modern cosmology. Gravity and dark matter, the cornerstones of cosmology, are under scrutiny. We've been taught since childhood that gravity is the glue holding the universe together. But some daring minds are challenging this long-standing belief, suggesting that electricity, not gravity, might be the fundamental cosmic force. These scientific rebels question the concept of dark matter, that elusive substance accounting for nearly 85% of the universe's mass, yet remaining undetected. They argue that dark matter is a hypothetical patch, a way to make the gravitational model fit with the universe's observed large-scale structures. Let's take a moment to remember Immanuel Velikovsky, a controversial figure whose work, Worlds in Collision, rattled the cages of orthodox astronomy in the mid-20th century. Velikovsky proposed that cataclysmic events in our solar system's history could explain many ancient myths. His ideas were met with scorn and dismissal by the established scientific community, yet some of his predictions have been validated over time. Similarly, the electric universe theory is often met with skepticism and even outright dismissal. Yet it persists, offering alternative explanations for phenomena that standard cosmology struggles to explain without invoking unseen, unproven entities like dark matter. Just as Velikovsky's work found resonance in the decades following his death, so too the electric universe theory is gaining traction. It's not just a theory penned on paper or debated in academic circles. The electric universe theory has even found a place in the laboratory. In the Sapphire Project, a star is born in a lab. This ambitious endeavor aims to bring the grandeur of celestial bodies right into our scientific playground. The objective? To recreate star-like conditions in a controlled environment. It's a bit like cooking up a small piece of the cosmos in a petri dish, if you will. The Sapphire Project isn't just about creating dazzling light shows in the lab, though. It serves a critical purpose in the exploration of the electric universe theory. By simulating the electric currents and magnetic fields typically found in stars, scientists can observe and study these phenomena up close and personal. It's an audacious attempt to bridge the gap between the cosmic and the microscopic, the celestial and the terrestrial. If successful, the Sapphire Project could truly revolutionize our understanding of the universe. This project could potentially validate the electric universe theory. Quantum entanglement challenges the speed limit of the universe. A concept that would have been considered science fiction not too long ago, quantum entanglement has taken center stage in the realm of quantum mechanics. It's a phenomenon that, at its core, seems to defy the very laws of physics as we know them. To understand this, let's consider two entangled particles. No matter how far apart they might be, a change in the state of one particle leads to an immediate change in the state of the other. This happens faster than light, which according to Einstein's theory of relativity is the ultimate speed limit of the universe. But quantum entanglement seems to be playing by a different set of rules. This isn't just theoretical musing. Scientists have tested and confirmed this bizarre behavior in the lab. Quantum entanglement is real, and it's shaking up our understanding of how information can be transmitted. Now, you might be wondering, how does this tie in with the electric universe theory? Well, both quantum entanglement and the electric universe theory challenge conventional scientific wisdom. They propose that the universe may be fundamentally different from our current understanding. The electric universe theory, for instance, posits that electricity, not gravity, is the primary force shaping the cosmos. It's an idea that, like quantum entanglement, faces plenty of skepticism and criticism. But as we delve deeper into the mysteries of the universe, we might find that these theories hold more truth than we initially thought. The electric universe theory, like quantum entanglement, faces skepticism and criticism. But if history has taught us anything, it's that sometimes the most revolutionary ideas are the ones that face the most resistance. As we continue to explore and understand the universe, who knows what other surprises await us? Not everyone is ready to plug into the electric universe theory. As with any radical idea that challenges established norms, the electric universe theory has had its fair share of skeptics and critics. Some have dismissed it as pseudoscience, while others question the validity of the supporting evidence. The proponents of the theory, undeterred by the criticism, respond with conviction, arguing that the theory offers a more comprehensive explanation of cosmic phenomena than mainstream physics. However, this skepticism is not just about the electric universe theory. It's about any unconventional scientific idea that dares to challenge the status quo. In the broader context, it's a reflection of how scientific orthodoxy might suppress innovative ideas, stifling the very spirit of scientific inquiry that it purports to uphold. The resistance to new ideas in some cases can border on censorship, where dissenting voices are silenced and unconventional theories are ridiculed or ignored. This suppression of unconventional ideas can have far-reaching implications. It can hinder scientific progress, as it discourages innovative thinking and the exploration of alternative explanations for observed phenomena. It can also create an environment where conformity is valued over creativity and where consensus is mistaken for truth. This is not to say that every unconventional idea is correct, but they deserve to be evaluated on their merits, not dismissed out of hand because they challenge established norms. But controversy and skepticism are not necessarily bad things. They are integral to the scientific process. They fuel debate, stimulate further research, and ultimately lead to a better understanding of the universe. They ensure that scientific theories are robust, having withstood rigorous scrutiny and criticism. Despite the controversy, the quest for truth continues. The proponents of the electric universe theory, like all scientists, are driven by a desire to understand the mysteries of the universe. They are willing to face skepticism and criticism, not because they are certain they are right, but because they believe in the value of questioning, exploring, and seeking truth. Whether or not the electric universe theory will ultimately be validated, the discourse it has sparked has undeniably enriched our understanding of the cosmos. The electric universe theory sparks a potential paradigm shift in our understanding of the cosmos. This theory challenges the conventional understanding of gravity, suggesting that electricity, not gravity, is the fundamental cosmic force. We've delved into the ancestral myths, hinting at past cosmic electrical events, and discussed laboratory experiments and archaeological findings that might support this theory. We've also critiqued mainstream scientific views on cosmology, particularly the role of gravity in dark matter, and referenced the disruptive work of Immanuel Velikovsky. The Sapphire Project, aiming to recreate star-like conditions in a lab, might just bring us closer to validating the electric universe theory. In our journey, we touched upon quantum entanglement, a fascinating phenomenon that challenges the speed of light as a universal speed limit. This led us to question Einstein's objections and ponder over the subsequent experimental validations. The skepticism faced by proponents of the electric universe theory cannot be ignored. We've addressed their critics and discussed the broader implications of suppressing unconventional scientific ideas. These themes of censorship, scientific orthodoxy, and the quest for truth are pertinent to the growth of science. If validated, the electric universe theory could revolutionize our understanding of the cosmos, but irrespective of its validity, it serves as a reminder of the importance of questioning, exploring, and being open to new ideas. Thank you for joining us on this electrifying journey. Stay curious, stay open. Until next time, keep exploring.